what's next? I suggest to experiment a little bit with coins in constructing the binomial coefficients. So I suggest you maybe start with three coin tosses, and 3 coin tosses should render how many different outcomes of heads? Well, 0, 1, 2, or 3, right? So for instance, imagine you toss the coin and you got and you toss the coin again, and maybe you got a tail, and then you tossed it again and you got a head, right? So that would be in this case 2 heads, and if you're constructing this table, it should go to the column with 2. So you should try all different possibilities, and we know how many possibilities should be there, right? We know that each coin toss can render either a head or a tail. So there's 2 possibilities for each coin toss, and we have how many tosses? We have 3. And that's why the total number of combination must be 2 power 3, which is equal to 8, right? So for instance, for 0 heads, what would you get? Well, you would get a tail, and another tail. So that would be 0 heads. It'll go into the column 1, and we know there's only one possibility, right? So how do you get 0? Well, no tail, no head, no head, no head, meaning tail, tail, tail. There's only one possibility. But if you think of the possibility of having maybe 2 heads, we already saw one, right? And that was that was how? That was a head, right? A tail and another head. But that's only one possibility, right? It is possible to get head, head, and a tail, or maybe you first got a tail and then you got 2 heads, and so on. So you'll write them all down, each combination in the line, and then tally up the number of heads here, right? So 0, 1, 2, or 3, and then when you add them all together up, it should be exactly 8 combinations, 2 power 3. Right, so that's how we would experiment with binomial distribution, coefficient of a binomial distribution, where the parameter n is equal to 3, right? So the outcome 0, 1, 2, and 3. It's a simple and fun exercise.